Okay, so in the last video ended, we were just finishing number 5. It's actually 5b, trying to find the velocity with which the teacher hit the ground. So the VI was 0. We found the height over here, 532.0725, multiplied by 9.81, multiplied by 2, take the square root, and you should get 102.71 meters per second. Down, of course. Okay? Which is like over 360 meters per kilometers per hour, which leads us to the second question, or the third question, which says, who designed this demonstration and why did she agree to it? That's what I want to know. Anyway, but if it was me, I know that hitting the ground would not hurt at all, because I would have died of a heart attack as soon as I fell. Maybe even before I fell, if I'm how high up? Like, that's an incredible height. What was it, 44 meters? Yeah, right. Okay, number 6. Number 6 says, a juggler performs in a room whose ceiling is 3 meters above the level of his hand. He throws a ball upwards so that it just reaches the ceiling. That means that as it gets to the ceiling, it stops. So he gives it some initial VI, which right now we don't know. Its A will be 9.81 meters per second squared down. And when it reaches the ceiling up here, before it hits it, gravity stops it. Okay, so he throws it perfectly. And it says the ceiling is 3 meters up. So the first part of the question is going to be pretty straightforward, because it wants to know part A, maybe I'll do it down here. With what speed did he throw the ball? So VF squared is equal to VI squared plus 2A delta D. And you're looking for VI, so take the 2A delta D over. So VI squared equals VF squared minus 2A delta D. But the VF is 0. So VI squared equals, so you have up and down here, so you need to call one way negative. So it's equal to negative 2, if we call down negative 9.81 meters per second squared, and the 3 goes in as positive. So you're going to end up with a positive, and it's going to be 6 times 9.81, 58.86. Take the square root and get 7.672 meters per second, and that will be up. Okay, so that's your part A. Now, continuing to read the question, it says, what is the time required for the ball to reach the ceiling? We can also do that. Okay, so you have delta D and A, and now you have a VI, and a VF. So probably the easiest one is A is equal to VF minus VI over delta T, which means delta T is equal to VF minus VI over A. The VF goes to 0. Delta T is equal to negative, that's 7.672 meters per second that you have in your calculator, divided by negative 9.81 meters per second squared. And so you get the time that it takes to reach the ceiling to be 0.78, is it 2? Oh, sorry, 0.782, yeah, it is 2. Sorry, I just couldn't make it out on the calculator. All right, that's B. C. At the instant when the first ball is at the ceiling, he throws the second ball upward with 2/3 the initial velocity. So what we were looking at was ball 1. Now we're looking at ball 2. So so it's going up, and the VI of ball 2 is 2/3. That's 7.672 meters per second that the other one had. Okay. How long after the second ball is thrown up did the two balls pass each other? So this is up. A is going to be equal to 9.81 meters per second squared going down. And we don't know how far it's going up. But what we do know, if they're passing each other or meeting each other, then we know that delta D of the first ball on its way down and delta D of the second ball on its way up must be equal to the 3 meters. Okay, so now the first ball's on its way down. Shoot, I should have written that down here. Sorry. Just to keep. So now the first ball's on its way down, so I should probably redo my givens. So the first ball is now on its way down. So its initial velocity is 0. Its A is 9.81 meters per second squared down. So it's speeding up while this one's slowing down. Okay, so the delta D2 here will be, this one's going to go up until it's, no, it's not. It's going to, delta D2 here will be VI delta T plus 1/2 A delta T squared. And delta D1 here will be VI delta T plus 1/2 A1 delta T squared. And what I wrote a few minutes ago that I whited out just because it was in the way is delta D1 plus delta D2 should equal 3 meters. Okay, so subbing this in and subbing, this VI is 0. Subbing this in, we will have 1/2 A1 delta T squared plus VI delta T plus 1/2 A2 delta T squared equals 3 meters. And this might look messy, but it's really not going to be. It's not going to be because for ball number 2, the A is going to be negative because it's going up and gravity's slowing it down. But for ball number 1, the A is going to be positive because it's coming down and gravity's speeding it up. But they're the same value, but one's going to be positive and one's going to be negative, which means these two terms are going to cancel each other out. Right? Because it'll be 1/2 positive 9.81 times the T squared, and we don't know the T, and this will be 1/2 times negative 9.81 times the same T squared. So they're going to go, and all we're going to be left with is VI delta T is equal to 3 meters, and we're trying to find delta T. So it'll be 3 meters over that 2/3 of 7.672 that I never did find in my calculator. Okay, so when you do that, you should get a delta T of, I think the bottom here, the 2/3 is 5.11468. And you should get a time of 0.58655 seconds. Okay, that's not what the question asks. The question asks, how long after the second ball is thrown did the two balls pass each other? Oh, it did. Did the two balls pass each other? So it did ask that, but it's not all it asks. The D says, what distance from the juggler's hand do they pass? So his hand is here, so I'd use ball 2 to find that. Okay, so for part D, it'll be delta D2 is equal to, because it's measuring up from his hand, the other one's measuring down from the ceiling. So delta D2 is equal to, so you do the 2/3 of 7.6, etc., and you get 5.11468 meters per second times the 0.58655 seconds plus 1/2 negative 9.81 meters per second squared times the 0.58655 seconds, and that gets squared. And when you do this, you should get a delta D of 1.3125 meters. Now you could have done it for ball 1. The equation would have been easier, but when you'd get the D1, it would be the distance from the ceiling, and you'd have to subtract it from 3 meters to find the answer. Okay, so that's the juggler, number 6.